Alright, so here we have our ellipse. The center is at HK. So this horizontal line is called our major axis. The reason it's called the major axis is because it's the longer one. So the length of the major axis goes from this endpoint to this endpoint. So in this example, the length of my major axis would be 1, 2, 3, 4, 5, 6. This vertical line is referred to as the minor axis, and it's going to be the shorter of the two axes. And so from endpoint to endpoint, that's 1, 2, 3, 4. So the length of the minor axis is 4. The endpoints that are on the major axis, each one of those is called a vertex. So I have a vertex here. So that vertex would be at 1, 2, 3, 4, 5, 6, 1. And then this endpoint over here is another vertex. And so that vertex would be at 0, 1. The endpoints on the minor axis are called the co-vertex. So right here is a co-vertex, and it is at 1, 2, 3, 1, 2, 3. And then this point right here is another co-vertex. And so it is at 3, negative 1. So the vertices, that's the plural vertex, appear on the major axis. The co-vertices are on the minor axis. You will know the major axis is the major axis because it is the longest one. The minor axis is minor because it is the shortest one. And inside is where we have the two focal points, F1 and F2. F1 and F2 are focal points. So the plural of focus, and I have heard it pronounced both foci, foci, hard or soft C. So if you see that word, that's just the plural for focus. Alright, so let's talk about the lengths here. We call the length that goes from the center out to the vertex on the major axis, that is A. And we call the length from the center to the co-vertex on the minor axis, that is B. And then a point or a length of interest for us is going to be the length from the center to the focus. And that length is C. And so there's a relationship with A, B, and C that comes from the Pythagorean theorem, but it's not going to look, the alphabets are not going to be the same as you're used to in the Pythagorean theorem, because C is not going to be the hypotenuse. All right. So if I come in here and make a right triangle that includes side C, and goes here, when I'm looking at this right triangle, this leg is C, and this leg is B. And this length, the hypotenuse, is actually A. Right, Ms. Collier, how do you know that's A? Okay, so the length from the center out to the vertex, if this is A, then from this center out to this vertex, that also has to be A. So that's a total of 2A. And so if I go from this focus point up here and back down again, that's also going to be 2A. So it's going to be A on this half and A on this half. So that's how we know that's A. So the hypotenuse is actually A. So we get the relationship that C squared is equal to A squared minus B squared. So it comes from a right triangle relationship in the Pythagorean theorem. But notice it's not A squared plus B squared like the Pythagorean theorem is. It's A squared minus B squared. And again, the reason for that is because the A is actually on the hypotenuse. All right, so what is the equation for an ellipse? So the equation for an ellipse that has a horizontal major axis is parentheses x minus h squared over a squared plus y minus k squared over b squared is equal to 1. All right, so we're going to pause right here. So that's a lot of different words. Turn and talk with your team. Pick a word. Describe it to your team. Everybody go around. Everybody say something. When we talk, we learn. Talk to each other.
From the center to the up and down spots.
Sides for inside. Yeah, that's what she explained. That's very sad. Well, it seems very
It's better when he is so good. I know you know, worst case scenario. I don't like it.
Oh, yeah, that's weird. So then you just vertex,
That's
center,
normally it's
All right, so let's come back together. All right, so all of this is for an ellipse that has the major axis on the horizontal. So now let's look at an ellipse that is oriented the other way. I'm going to draw an XY coordinate plane. And I'm going to choose a point to be the center. I'm going to choose 4, 2. So that's my center. I'm going to go up 1, 2, 3, 4. 1, 2, 3, 4. And then I'm going to go out 1, 2, and out 1, 2. This is F1, F2. All right, so we want to go through and label everything on this graph. We'll start with our center, right? So the center is here. The center is labeled HK. In this case, our center would be 1, 2, 3, 4, 1, 2. All right, so being able to know where is the center of an ellipse, that's one important thing. And then you'll see that we have these two axes. So we have an axis that goes here, and we have an axis that goes vertically. So the longer axis is the major axis. So this time, the major axis is the vertical one. So it all stems from which axis is longer. The major is the longer one. So the length of my major axis would be 1, 2, 3, 4, 5, 6, 7, 8. So then from endpoint to endpoint here, this is my minor axis. And so the length of my minor axis is 1, 2, 3, 4. So the other points of interest to us are the vertices. So the vertices are now on the major axis. So this point up here is a vertex. And it would be at 4, 6. And this vertex down here would be at 4, negative 2. So notice, if you will, that the x-coordinate for your vertex, the x-coordinate for your center, the x-coordinate for your other vertex, they're all the same. They're all h, because they're in line with each other. So then on your minor axis, this point right here is called a co-vertex. And that would be at 2, 2. And then this point over here would be your other co-vertex. And that would be at 6, 2. So then notice that your K, which is at 2, and that's that same value on your co-vertex. Which makes sense, right? All right, so what about the equation here? The equation this time goes x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So take a moment and compare these two equations. There's certainly a lot that's alike, but what's different about them? See that the A and the B are switched? Okay. The A always goes with the major axis. A is always going to be bigger than B. A is always bigger than B. So A goes with your major axis. So here, my major axis is vertical, so my A squared goes with the Y term. Up here, my major axis was horizontal, so my A squared went with the X term. That's the difference between the two. All right, so let's look at an example. If we're given an equation and we're asked to find some different things about it. So here's an example. Let's just say I have x squared over 36 plus y squared over 49 is equal to 1. All right, so some things I should be able to know by looking at that equation. What's the center of this ellipse? So your center is HK. What's my center here? Am I subtracting anything at all? So isn't that x minus 0 and y minus 0? So this center is on the origin 0, 0. Is my major axis going vertical or horizontal? Vertical. How do you know? All right, so what we're thinking in our mind is 49 is bigger than 36, right? So, vertical major axis. Because it's with the y. Alright. So that means that a squared is 49, true? So if a squared is 49, how much is a? 7. So I could come start to draw my ellipse. I have a center at 0, 0. And I need to go up 7 and down 7. And those would be my two vertices, right? So I have a vertex at 0, 7. And I have another vertex at 0, negative 7. So what's the length of my major axis? Seven plus 7, 14. All right, so now let me figure out what B is. If B squared is 36, how much is B? Then I can come over on my graph, start at my center, go out 1, 2, 3, 4, 5, 6 from the center. 1, 2, 3, 4, 5, 6. So this is my co-vertex, is at 6, 0. And my other co-vertex is at negative 6, 0. And I could come sketch that ellipse. Now, the hard part is, where are those focal points? Where are those focal points? Well, here's what I know about my focal points. My focal point is C units from the center. And so I know that C squared is equal to A squared minus B squared. Well, A squared is 49, and B squared is 36. And if I do 49 subtract 36, I get 13. And then if I take the square root, so C is the square root of 13. So that's the distance that the focal points are from the center. So the square root of 13, let's think. 3 squared is 9, and 4 squared is 16. So the square root of 13 is somewhere between 3 and 4. I'll just go up 1, 2, 3, somewhere in there. Focal point 1, 3, focal point 2. And where is that point? It's at 0, square root of 13. And where is this one? It's at 0, negative square root of 13. So from the center to the focal point, that is C. All right. Choose one part of this and talk to your team.
So if you put, yeah, so the square root of 9 would be 3, the square root of 16 would be 4. Somewhere in between.
All right. So for the next 10 minutes, we're going to practice this about ellipses on iExcel. So it's iExcel P7. There's a link for it on your Canvas if it's easier for you to get to it that way. Out P7 on all our iExcels. Again, we're going to go Smart Score 80, equals half square of 100. SMART score gets up around 60, you may need to write some more things down. If you get to where your center is not at 0, 0 anymore, it takes a little more calculations. Those first few you can do mentally, but as they get more difficult, remember it might help to sketch what's going on. That might be useful. 8. Yeah, when I did it last night, I got up to 67, and then I got one wrong because I was like, oh, the center's not at 0, 0 anymore. I forgot about that. finish up the question that you're on, but don't start another. And just put your screen at like a 45-degree angle. We're going to go on to the next part of our notes. Yes. All right, so the next thing we want to talk about is just more of an idea than a calculation. We're not going to spend a lot of time calculating eccentricity. It's actually very easy to calculate. It's just a fraction. So remember, this letter C is the distance from a focal point out to the ellipse. So this distance here is C. The eccentricity is the ratio of C to A. And A is your distance on your major axis. So if this ratio is close to 1, you have like a extended, expanded, spread out an ellipse. But as the two focal points get closer and closer together, and then you get to the point where the focal point, the two focal points are actually the same point, then your ellipse becomes a circle. So a circle is a special type of ellipse. A circle is an ellipse, but it's a special ellipse because it only has one focal point, which is actually right in the center of the ellipse. So the eccentricity is 0. Think about eccentricity as being like just how spread out that ellipse is. Which makes the equation of a circle actually much easier compared to our general ellipses. So if we take the equation for an ellipse, x minus h squared, and we've got y minus k squared, And if my ellipse is going this way, then my a squared would be here, plus b squared equals 1, right? General equation of an ellipse. But if I get to the point where that focal point is right in there, then b squared is actually the same as a squared, right? So for a circle, b squared equals a squared. This distance here, which is a, and this distance here, which is b, they're exactly the same. So my equation becomes x minus h squared over a squared plus y minus k squared over a squared equals 1. Because b squared and a squared are exactly the same amount. Well, at that point, I can take this entire side of the equation and multiply it by a squared. And then I'll multiply the other side of the equation times a squared. Now watch what I'm doing mathematically here. I'm distributing. So this is a squared over 1. So if I multiply a squared over 1 times this fraction, my a squareds divide out, and I have x minus h squared. And then if I multiply a squared over 1 times my second term, and I multiply these two fractions, those a squares divide to 1, and I just get y minus k squared. And then this side is equal to a squared. But since we're talking about a circle, and look at where a is, isn't that the radius of a circle? A is the radius, after all, in this case. So we just write x minus h squared plus y minus k squared equals r squared. R for radius. So that's going to be the equation for a circle. Circles are a special type of an ellipse. They're an ellipse that has an eccentricity of 0. The two foci get closer and closer and closer until they actually become the same point. And that's how your ellipse kind of condenses into a circle. So the equation for circle is actually easier than ellipse, but it's going to have a lot of the same characteristics, right? So our center of our circle is at HK. If that wasn't obvious to you, that H and K is the center of the ellipse. That H and K is also going to be the center of the circle. And R is equal to the radius. So whatever that number is, take the square root of that, and that's your radius. So, if we look at an example together, if I have the equation x minus 2 squared plus y plus 3 squared equals 16. The center of my circle is going to be at 2, -3, and the radius of my circle is going to be the square root of 16, which is going to be 4. So with that information, I could come and draw the circle. I would go to 2, -3, put my dot for the center of my circle, and then I'd go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 in all directions, and I'd be able to sketch a circle. All right, turn and talk to a partner. One of you explain eccentricity, and one of you explain this example of a circle.
Eccentricity how spread out so you can make an ellipse. And then when they come together, it makes a circle.
The example was just a lot easier to find numbers in this situation. And it's also easier to figure out the circles. The other shapes that were
All right. So here's your assignment, guys. P7, some of you already finished it up to 80. Some of you are real close. You can finish that up to 80 before we leave today. P4 and P5, these are circles. The circles are actually going to be easier than the ellipses. For all of these, the same rule applies. Smart score 80 is hack score of 100. So we have 8 minutes left. Go back and knock out P7. And then you have P4 and P5. All right, as we start a new year, some of you need to create some type of system for staying better on track for your assignments. So think about what would work for you. Is a paper and pencil method going to be best? Is an electronic calendar going to be better? You either need to get in the habit of, okay, every day I'm going to check Canvas and see what's on there for pre-cal, or are you going to keep an assignment book, or are you going to set a reminder in your phone? Like, make a system. Because a lot of you saying that you just forgot about your homework. Well, how are you going to not forget in the future? Are you going to make a system to be able to check off your work when it's done?
Canvas hasn't been updated, or the calendar that you have on the homepage.
It's on the different.
Go to the spring.
Yeah.
What?
Yeah.
Oh, man, I didn't see it.
Yeah, your other ones should have disappeared today. They said they were going to.